Okay, so a couple more examples of synthetic division here. This first one, try it on your own. Pause, try it on your own, see if you can do it, and then come back and check and see if you got it right. So remember, with synthetic division, it's when you're dividing by things of the form x minus r. So in this case, r is 1, so that's the value that's going to go here. Then we put our coefficients in order. There we go. And then we just start. So we bring the 1 down. So the first coefficient comes down. We multiply. We add. We multiply. We add. We multiply. We add. Done. Okay, so our solution here is, again, we want to go 1 down from the dividend, 1 degree down. So we have x squared plus 4x plus 2, and that's going to be a remainder of 3. So we have this, and then this, and plus 6. So what it's telling us is that x minus 1 divides into that polynomial with a remainder of 6. So that's what we want to kind of remember there. Now we have one more example. Again, you can pause and try this. If you want a little bit of a hint, it's going to be x minus a negative 2 to think about, because we want the form x minus r. And so that's going to put a minus 2 here. So that's the only thing to remember. Otherwise, it's very similar. So go ahead and try it. Okay. And I'm going to bring down that 2, and I'm going to multiply, and I'm going to add, and I'm going to multiply, and I'm going to add, and I'm going to multiply, and I'm going to add. Interesting. So this is an example where your remainder is 0. And what that means is that when you do this division, you end up with 2x squared minus 7x plus 3. That's what you get when you divide. And understand that what this is telling us is that x plus 2 times 2x squared minus 7x plus 3 is that thing we started with. Exactly. So what it's telling us, I want you to really understand, because this is where it's key, is that x plus 2, what this means is x plus 2 is a factor of that polynomial, because you can divide it evenly, is I guess the word I'll use, into that original polynomial, because the remainder that comes out is 0. Over here we have a remainder of 6. That one has a remainder of 0. So it is a factor of that polynomial. Okay. Okay, so now find a polynomial function of lowest degree that has these certain zeros. So what I want you to see real quickly is, for example, if we have 2 as one of our zeros, that means that x minus 2 is one of the factors, because it means that if I take my function, so I'm just like creating this function x minus 2, so it's not very exciting. But when I create this function x minus 2, if I set that equal to 0, that tells me, of course, that the value of 2 is going to make my function 0. Okay? So that's what it means to have a 0 of a polynomial function, that x minus 2 is a factor, is one of the factors. So we can do the same thing with all of these. I'm going to call it p of x. We can do, so what I'm going to have you think about here, because we have more than just that one factor, is x minus 2 has to be a factor. This is what's kind of interesting, but it's kind of going backwards. That's what I'm going to say. It's going backwards because usually we're like, here's this polynomial, find the zeros. And we have to factor, or now we could use synthetic division. We might need the quadratic formula. We have these different things we can do to find the zeros. In this one, it's like, here's the zeros. Well, what's the polynomial? So it says find a polynomial of lowest degree. So that means by having 4 zeros, we're going to have a polynomial of degree 4. So it should have 4 factors here, where each one is an x minus, and then of course, whatever that 0 is that we're being given. So it's, one of them is 2, so we have x minus 2 as a factor. One of the zeros is 1, so we'll have x minus 1 as a factor. One of the zeros is a negative square root of 3, so a minus square root of 3 is a positive square root 3. And then the other one is a square root of 3, so x minus square root of 3. And then the idea would be to actually have the polynomial. In polynomial form, this would be multiplied out. Here's a hint. Start with this. Start with this because this is the difference of squares. You have the same things in each one except opposite signs. So because of that, multiplying this out would actually be together would be the best idea. So we're going to do, so I'm just saying, like, if you want to make a note here, start here. So we're going to multiply this out. We want it in polynomial form. So p of x, I can also, if I want, multiply the first 2 out. That's fine. So I can also do these 2. So that's going to be a trinomial, x squared minus x minus 2x, so minus 3x, minus 2 minus 1 plus 2. And then again, like I said, this is the difference of squares. So we have x times x squared. Then we're going to have a minus x times the square root of 3. And then we're going to have a positive x times the square root of 3. That's 0. That's great. It's gone. And then we have the square root of 3. So we have minus the square root of 3 times the square root of 3. That's the square root of 3 squared. Those are opposite operations. Squaring, square rooting. So if I have square root of 3 squared, I just have 3. So there we go. So now we have a trinomial times a binomial. And then of course it just comes down to writing that out. So multiplying that out. So notice you have 3 terms times 2 terms. So that should give you 6 terms. And then you might be able to combine some like terms. So I'm going to start with my x squared and then multiply it by both terms in the binomial. X to the 4th minus 3x squared. Then I'm going to take my minus 3x and multiply it by both terms in the binomial. Minus 3x cubed plus 9x. Then I'm going to take my 2 and multiply it by both terms in my binomial. 2x squared minus 6. Now I'm going to see, is there anything I can combine? So I have x to the 4th. I'm going to also put it in order, just because that's what a polynomial is descending degree. I can combine the minus 3x squared with a positive 2x squared. I've got a plus 9x. I've got a minus 6. And I always just double check with my notes, because if I make one mistake, sometimes I have to do the whole video over again. We don't want to do that. So there it is. So that is the lowest degree because it has a degree of 4, 4 zeros, degree of 4. And that's our polynomial written in polynomial form. Now, this takes us just one more step further. It wants a polynomial of lowest degree that has the same zero. So I'm going to start off already by just writing out what I had from before. Yay. Okay. But now we're also given this piece of information here, which is that for this polynomial, when x is 1, when x is negative 1, the y value or the function value is 4. So you might be like, well, what does that matter? When you look at this original polynomial, it has those 4 zeros, the ones that we decided. The only difference, the only thing that could be different with this polynomial and any other polynomial that has those zeros is a value in the front of it. So we're going to call that a. So A could be anything. And as we've kind of learned with transformations, depending on what A is, you may find that your polynomial has those zeros, but say for example, maybe it's like a lot stretched out, you know, it's like, maybe it's like this, maybe it's like this. And that A is what's doing it, that factor in the front. So we need to find what A is when we have this point that's on this special polynomial, that when x is -1, y is 4. So input is -1, output is 4. And we can basically just put those values into what we have here to solve it for A. So we know that out should come 4 when x is -1. So we simply plug in a -1. So then we have +9, -1, -6. And then we just evaluate this. It's just a number. So 1 minus 3, oh, it's going to be a +3 because of negative, negative. And then -1, -9, -6. And when we just add and subtract that, it looks like we are going to have a -12. Dividing that gives us a -1/3. So we're dividing both sides by -12. 4 divided by -12 is -1/3. So what it means is that A, the constant in the front of this polynomial, is a -1/3. And for that new polynomial, it's going to give us the special point, -1/4. And I don't mean special, I just mean that that point is on this polynomial. So our polynomial becomes, now I'm just going to multiply each term in that top one, and multiply each term there by that -1/3. So I should have a -1/3 x to the 4th plus x cubed plus 1/3 x squared plus, nope, minus 3x plus 2, it looks like. Let me double check that with my notes. Looks good. Okay. And so that's it. That is section 3.3. However, I am going to show you what these two polynomials look like so you can see how they're similar and how they're different. So let's take a look at the last two examples from section 3.3. The red function that you see is a polynomial. Notice that it is smooth and continuous, and it's the one that we found that has zeros at 1, 2, plus or minus the square root of 3. So notice we have, this is the 0, this is negative square root 3, it's a decimal form. This is positive square root of 3. We have the 0 at 1 and we have the 0 at 2, so where we're crossing the x-axis. Then we notice our function that's in blue. This is the function where we found that A is -1/3, but it's just a number that's being multiplied by every term in that polynomial, the red polynomial. So what I want you to see is, yeah, it looks different. You should notice it's still smooth and continuous, it's still a polynomial, but there's an aspect of it being flipped because of the negative that's in the front. And the other big thing, of course, is you still see the same zeros. So that's really the key, is that the zeros are still the same. It still crosses the x-axis at the same values. The only difference is that that A changes kind of how it stretches, whether it, whether it does this or whether it does this. That's what's happening there. Actually, I should say this or this because it's an even, both of them are even polynomials of even degree. But notice similarities and differences here. Key thing, they have the same zeros.